Hey everyone, this video we're going to be looking at taking up this free body diagram worksheet. Okay, so I just want to give you some tips when we're dealing with these free body diagram worksheets. Remember, we're just drawing sketches. We don't have values yet. We're going to be doing those soon. When you're doing these, I like to work backwards actually. I like to look at the motion and from the motion figure out the overall forces and then draw my free body diagram. You'll find it might be helpful for you. All right, so the first one here, what we have is we have a textbook resting on your desk. We've seen this one 1,000 times, very easy. So what's going on? We're resting, so it means our acceleration is 0, and the overall forces must also equal to 0. They're all balanced. And then as a result, so let's sketch the forces acting on me, or on the textbook, sorry. They're going to be gravity, which we already know, and because they all the forces have to cancel, I just have normal force, and the arrows should be the same length in opposite direction. That's it. Okay, let's look at the next one. We have a basketball falling to the ground from a basket. So it's accelerating. So it's going to be accelerating downwards. So my overall sum of forces must be downwards as well. And let's look at the forces acting on me. I'm going to have gravity. There we go. And what other forces are there here? I only have air resistance. So I'm not on a surface. Nothing's holding up the basketball. So it's just a little bit of air resistance. And because I'm moving downwards, the air resistance must be upwards. It's opposing my motion. Okay, so don't forget, opposes your motion. So you got to be careful for air resistance. Sometimes it's going the other way. All right, next example here. What do we have? You got a car being pushed at a constant velocity with friction between the wheels, and you also have air resistance. You got two types of air resistance. Well, important word here, constant velocity. That means my acceleration is 0. The overall sum of forces must also be 0. So what are the forces? Well, we're going to have gravity, we know, and the normal force because we are not falling. We're going to have some kind of air resistance here, so it's going to be friction force. And we also have friction between the wheels. We have a couple of friction forces here. You can have 2 of them. Just put them, superimposing or just offsetting them a little bit. And now the applied force should be the sum of these, so about twice the length. And that's going to be the engine force. And that's it. So again, very, very, very straightforward. I think you're getting the hang of them after a while. Okay, what do we have here? We got a toboggan. It's accelerating. It's being pulled by a horizontal rope on a horizontal surface. So what does that mean? Well, we're accelerating. So I have an overall force that's going to be forward. And what else do we have? We got some, let's see what we have happening here. We got gravity. I'm going to have my normal force. I'm being pulled by a rope. You got to be careful. So I'm going to have some kind of tension force happening here. And we're accelerating. So we're going to have a little bit of friction, but it's going to be smaller than my tension force to give me that overall F net. And that's it. All right, next thing, we got a hot air balloon being pulled down to the surface with a rope. So we're assuming that we're accelerating downwards. We're not being pulled down at a constant speed, but we're accelerating downwards. So again, that means that my overall force must be downwards as well. So make sure you show the acceleration and your overall force in all your diagrams. Very, very important. You don't want to lose marks. So the hot air balloon is going to have gravity acting on it. Even though it's a hot air balloon, it still has gravity. It is being pulled downwards by some kind of tension force. I don't know how long it is. I'm just going to put it in there. And we're also going to have some kind of buoyant force. Let's just call it F for now. And this should be a little bit smaller than the sum of these two together. I'm just going to call this F to give you the overall downwards acceleration. All right, let's look at the last one here. We got a baseball being thrown up in the air with air resistance. So what's happening? You're pushing the ball up into the air, so we know we have to have an upwards acceleration. So the sum of the forces have to be upwards. What are the forces involved? Well, first of all, we always have gravity, we know. I'm also going to be pushing this upwards. How about air resistance? Well, I'm throwing this upwards, so the air resistance must counteract my motion. It's going to be downwards. And that's it. So again, when you're drawing these diagrams, try to start with the motion, indicate the acceleration, show the overall force, and then draw sketches of the individual forces, making sure that the vectors are the appropriate length. Okay, that's it.